everyone. Welcome to my session. I'm Sahar Rahmani from RBC, and I'm here to talk about how AI can help save time, money, and your customers' information, or on the other hand, application of data science in cybersecurity. For our agenda today, I'm going to talk about JSOC and JSOC analytics at RBC, application of data science, real world application of data science in IAM, identity access management, in fraud detection, and in malware detection. And also I'm going to briefly touch point on lesson learned. Lesson we learned during the last few years at JSOC. So JSOC, last few years with the increase of amount of the data and modern technology, RBC come up with the concept of having joint security operations center at RBC. So this team are having the four main pillars: offensive security team, adversarial emulation team. They are a group of offensive security people who try to hack the system from the inside. So they come up with the innovative way to hack RBC's different systems, and in this way find all the vulnerability or issues like are currently in our defense in our controls at RBC. Threat hunting teams, their mindset is there are already threat bypass all of our security controls, and they are already in the system at RBC. The way they are technically hunting for all the issues that are either inside the network or in our digital channels to find malicious codes or malicious behavior at the bank. We have application development team that working on supporting threat hunting, adversary emulation, and analytics team application related work, and also they are closely working with us to serve data science models to our customers in real-time format. And at the end, our JSOC analytics team. JSOC analytics team are consistent. This is a snapshot of people who are currently working at that team. It's a team of 13 data scientists, 7 PhD, 6 master. They are data scientists, machine learning engineer, or data engineer, and they are working together to detect threats in various pillars of the RBC, like in fraud management, in identity access management, in AML team, and other pillars at RBC, using AI and machine learning techniques. So, like 3 years ago when I joined RBC, this group of people were only 3, or 4 at max. And then I remember when I joined as a data scientist, and we were talking about the ideas and how we want to solve cybersecurity or threat detections at RBC using AI. There were people who would say that never going to happen, like cybersecurity and AI are not going to be successful program. They are not at the bank anymore. And we proved that this is going to be, this is work, and why it's even interesting and mandatory for companies to bring that capability to their companies. So this is a story of us to tell you how cybersecurity is, how AI helped cybersecurity to detect threats. So this is JSOC analytics work at the snapshot. We work with FinCrime team. The use cases we are currently working is called identifying fraudulent transactions, digital risk score. If somebody logging on digital channels at RBC, how we can determine that's the same person, the owner of that page is logged in, or somebody else pretend to be that person and take over those sessions. Check analysis, using AI to identify fraudulent check analysis and phishing detection. So identifying phishing websites, phishing emails to prevent any issues that might happen in through the phishing capability. On the identity access management, we identify risky attestations, like the ones that definitely needs to be attested. We do role mining for people who are familiar with identity access management. Role mining means like to define roles based on the entitlements. Jargon detection in the bigger companies, like as in the company as big as RBC, and I'm sure like anybody who works with the big companies know of lots of the accesses and permissions have lots of jargons like that is not easily identified by managers. We detect those jargons and make sure to clean up all those attestation, all those lines, and outlier detection if somebody access to a system that they shouldn't have. In the cyber side, we work in twofold. One, we are delivering machine learning as a service, big data analytics as a service, also data as a service, meaning that we have a big data lake that we ingest lots of our security controls logs in the lake, and we clean them, we parse them, and they are ready to use. Originally, the usage was for my team to deliver, to use it for model development and prototyping, but later on we realized there are lots of people, incident response team, threat hunting team, other teams need to have access to those data, and making it clean and ready to use for them is an asset. So we are opening our lake to other people in the cybersecurity team at RBC that need those data for their day-to-day job. Also, we have a production environment. We create a production environment for data science. As we said, as I said before, like we have a data lake, and then like we have an environment that helps to develop the model and put the model in production and serve to our customers. The other group of work we do, body of the work we do at Cyber, we do user behavior analytics, we do malware detection, we identify people who are in flight risk and in risk of data exfiltration. And also, Data Guard is a code name for a project that identifies anomalous access to our data sources. So these are a snapshot of use cases. We are working at GCS currently at this year, and the mandate is growing because people are learning more and more about usefulness of bringing AI insight in the problems in the risk and security problem at company. So let's talk about identity access management. For people who are not do not have a security background here, identity access management, or IAM, is a framework of business processes, policies, and that used to manage user identities and accesses. So technically, maybe like in a startup companies, it's not that pressing issue, but the companies become bigger and bigger. We have to think about how to protect our data, who is going to have access to those data, and the systems. Like not everybody get access to all the data on the system at companies. You have to protect your information, which reduce the risk of insider threats or risk of stealing, or even if the part of the company's network or a computer of the person got infected with the malware, it reduce the effect of the issue. So IAM team are responsible for defining individuals in the system, defining roles in the system, and how the roles are assigned to individuals, adding, removing, updating individuals and their roles in the system, assessing level of access to individuals and the group, and protecting crown jewel information within the system. Again, like people who have a management experience at bigger companies, they know that usually there are attestation practices. You have to go for people who report to you, check that if the accesses they have is okay or not, like if they still need to access a specific data, a specific system, a specific capability or not. And usually this is like it needs lots of energy from the management and IAM team to identify all those people and send the campaigns, and managers have to go through sometimes hundreds of entitlement to approve them one by one. So one thing we are doing with with our IAM team is coming up with a technique to identify outliers. The reason we are doing it is to help reduce the attestation work for managers. The idea is if, for example, all the data scientists in the team are having the same access or having the same access to non-risky environment, it's probably part of their job. But if somebody in the system has access only to one or two of the entitlement and nobody else has those accesses, it means there's something going on. Either that person has a specific job that nobody else in her or his team has access, or like it's usually like the case that they moved from one team to other team and they forget to remove the entitlement, or in the most extreme case, it's an insider threat. That person get access to the system to steal some information that they shouldn't have access to. So to do that, first of all, we have to do some sort of role mining, meaning that infer role of the users and entitlement for each role based on the user's entitlement information. So what we do is we look at, for example, in this picture, you see there are people have entitlements, access to the specific system, and like for row 2, 3, 4, everybody has access to that. That means we can identify role 1 for people who have access to those only those 3, and then we can identify role 2 and add row 1 of the data to them as well. So this is a very hard work in the system because yeah, like there are tons of people working and each of them has like 100 above entitlements, and it's very computational, expensive, and having a correct entitlement sometimes is really tricky. But for outlier detection, we need to go through this exercise, and then we need to find common entitlement and detect the outlier detection. There are so many techniques you can do that. You can use matrix factorization, which is just take matrix of people and entitlement and factorize them to 2 matrix of the role and entitlement and people and role and entitlement and people and roles, and then come up with the roles for each person, and then like look at the difference between entitlements and mark them. The technique works very well for small companies because, as most of people know, the matrix factorization is very, very heavily computational heavy. So doing that for on a big companies is just like almost impossible. So one thing we can do, and we did, and it works, using the local density models. Define people in the smaller group, not very small, like maybe instead of having hundred thousands of people, have 100,000 people. Smaller teams, like I'm sure each organization have their own org chart. So based on what makes sense for the org chart, define people in the smaller team. And just be careful to not go too small as well. Do not go manager base or senior manager base. It should a balance between the size of the people you want to look and how you want to define. That's a part of the feature selection that you have to work on. And then I'd use any density model to define outliers. Again, based on the previous talk, you probably know we are data scientists. We just develop the models and send the results out. So an analyst, a person who knows that area very well, area of their work very well, have to look at the results and identify if it's okay or no. So our job would be finished here to send the outlier to IAM expert. And IAM analyst would look at those results and say, yeah, these are anomalies, and send it to managers to identify if it's good or not. And managers can say, yes, turn the red to blue because the person has a specific assignment, or say, no, we have to remove that attestation. The other use of AI, and we are using it at RBC heavily, is for fraud detection. We are using AI to save money on fraud losses. And fraud can come in many different ways, like fraud in credit card, check fraud, debit card fraud, transaction fraud, insurance fraud, tax evasion, healthcare fraud. So practically most of the companies will, especially the one has a customer-facing companies, will face fraud in many, many different ways. And fraudsters are very, very smart. Remember, not only protective team, like the people who are protecting the company are using AI, people who are attacking companies are using AI nowadays as well, right? So they have, most of the methods we are developing are open sources, so they have their own they have their own techniques, they have their own infrastructure, they have their own data to come up with the newer techniques to commit frauds. And as I said, there are so many ways of doing that. Our best hope is to come up with a model that's robust enough to detect all the different ways of frauds. So if you search in internet fraud detection using AI, there are tons of models. And again, based on what is your usage and what is your problem, there are tons of solutions for each problem and what type of the data you have. One of the things we did at RBC, and it works, it's bringing millions of saving on fraud losses per year, is combining graph analysis with machine learning. So graph analysis is good for identifying connection between people, establish connection between networks, identifying the cluster of people, and anomaly detection. And machine learning helps with because fraud is a good example of using AI, mostly because most of the company have a known fraudulent previously known fraudulent activity, so they have a labeled data for those activities. Therefore, we can use any supervised model, again, based on the size of data you have, based on the features you have. There are tons of supervised models that can help you to identify fraud. But one thing I learned is ensemble models usually work better than a standalone model. And again, it's based on the experience, not based on fact or math. There are models that can solve, there are single alone models that can solve a fraud problem very well, but ensemble model will work very well in the fraud detections environment. So the other part of the work we are doing, and it's really, I would say, novel compared to in the AI world, not in the like traditional world, is a malware detection. How protect your client's information from malwares? For people who are not familiar with cybersecurity concept, how malware works are usually they initially compromise the system. The way they are coming, like it could be in anything, from the phishing email or somebody download something from the dodgy website without noticing. And again, like traditional way of detecting malware and protecting information, usually like 99% of those malwares. But fraudster attackers become more and more smart, so they come up with the new ideas to infiltrate the system. When malware is in the system, they try to connect with their command and control system. So they try to ping a website that they can send the information out. The moment the connection is established, they send the information out. So one of the best way to do that is using domain generation algorithm like DGA that uses the random string, random values to create URL. And there is a piece of code in the malware. There's the same piece of code is in hacker's computer, and then it keeps generating URLs. And in the malware from the computer, just keep pinging different URLs with a different timing. And the moment one of those like work, is just it's just like it's now like time to send the information out. So the way to avoid the command and control domains, usually like companies block the IPs or single the IPs. But again, there are so many new techniques coming. Some of those algorithms are really smart. So in malware detections, like how to stop the malware, one of the best ways to stop that DGA algorithm, to stop those successful connections. And how we did that is we come up with, we use neural network to define DGA detections and find like if there is a computer trying to connect into domains that are not good domains. We train our model based on lots of public data, Wikipedia included, and for domains we have there are lots of websites that provide list of good domains. We use millions of good domains and we generate the random domains. So like our input domain includes very good, like something like Google, Yahoo, Amazon, and we generate random domains that not really look like DGAs because like it doesn't have a numbers or anything, but it's very good in terms of like it's a random wording. And our model detects DGAs with 90% accuracy, which means if there is a super smart DGA that generates lots of good random domains, we still can detect them with a very high accuracy. So lesson learned. So yeah, like as I told you before, when I joined RBC, like when our team was 3 people, somebody told me it's not going to work. And I'm not going to lie, it wasn't an easy way. We had lots of support from our hire manager, also lots of support for other teams to be patient for us, to teach us how the system works, the model works. But now it's working. Now we prove that we can use AI to save millions in fraud losses, avoid reputational losses with losing our information, like customers' information. And also we can save hours of employees and managers' time just making our attestation system a bit smarter. So yeah, for doing that, you need to have a good set of data. You have to understand the business problems. Always talk to the business and think about what is their problem and what you are going to solve for them, rather than, oh, I want to solve every problem in the world with using AIs, right? That shift of mindset would help a lot to make sure you have a successful product for your group. So thank you very much for listening to my talk.